Hey class, welcome back to lesson number 8 already. I hope you're doing all right with these lessons, and I know it's not exactly the same as being in the classroom, but just do what you can, and remember to be filling out the yellow ones that I'm highlighting in the packet or on a separate sheet of paper. Okay, so today I wanted to quickly review the steps of factoring. So I have this list for you here. Step number 1. Always factor out the common monomial if possible. And remember, the common monomial is the biggest thing that each term has in common, including numbers and variables. Step number 2 is what we're going to learn today. Step number 3, after you've done step 1 and checked for step 2, then go to step number 3. If your leading coefficient is 1, that's where you just need to do that x factor, where you put the constant at the top, the linear coefficient at the bottom, what two numbers multiply, and they add, and put them in the bubbles and you're done. But if not, then go to step number 4, and that means that your leading coefficient is not 1, so that means you need to do the x in the box method that we covered in lesson 7. Okay, so here are your steps of factoring. There's also a different form of factoring. It's called grouping. We might get to that later on. We might not. But just know that this is kind of your general guideline, things that you should be asking yourself. It's not in your notes, so I would probably suggest writing this down somewhere so that you have it in your packet. All right, so in order to fill out number 2 today, we need to review something. We need to review something. So, what is 1 squared? 1 times 1, 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. I would expect you to have up to there probably memorized, but we're going to go a few more. 13 squared, 169. 14 squared. If you can remember, 13 squared is 169. 14 squared is 196. Okay, they just kind of flip-flop. 15 squared is 225. These are the ones that I would expect you to have memorized. Create yourself some flashcards, okay, any way that you can. Go through them, practice them, memorize them, okay? The easier you can decipher that something is a perfect square, which by the way are all of these answers, okay? These numbers are what are referred to as your perfect squares because it's a number squared. And I like to call them your purple perfect squares, just because I usually write them in purple. So your purple perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 141, 169, 196, 225. Have those memorized, okay? Because they're really, really, really going to help you with what we're doing today, which is step number 2 of factoring, which is special patterns, okay? I know how much we love to not be able to do work and just look at something and know the answer, so that's why we like number 2. That's what we do, special patterns. So, my 2nd through 5th period, if you remember when we did the special patterns for multiplying polynomials, this is just the reverse of that, okay? So if there's a special pattern to multiply polynomials, there should be a special pattern to factor the polynomials. And there is. So that's what we're going to learn today. Cool. All right, so factoring, special patterns. Ready, begin. Part 5 in your notes. So first we're going to start with the example 1, 4x squared minus 12x plus 9. and you're asked to factor this. Well, the steps of factoring. Is there a common monomial? 4, 12, and 9. Yes, there is, and it is, just kidding. No, there's not. I was thinking 3 because of the 12 and the 9, but there's not a common monomial. Okay, so step number 2, is it a special pattern? Well, I haven't taught them to you yet, so we're just going to skip to step 3. Is the leading coefficient 1? No. So it's not 1, so you would have to x and box. So if we were to do the x, oh, got the highlighter on still. Okay, so x. Remember, you're multiplying a times c. So 4 times 9 is 36. And then negative 12 would go at the bottom. What times what gives you negative 36? But when you add it together, you get negative 12. Negative 6 and negative 6. So you get negative 6 and negative 6. Now you have to plug it into the box. Remember, your first term goes in the top left box, 4x squared. And your last term, 9, goes in the last lower right box. And then your two numbers that you came up with, your outer and your inner, go in the diagonals and adding the variable. So then you should be asking yourself, what's the greatest common factor of 4x squared and negative 6x? Well, 2x, right? So 2x, and then working backwards, 2x times what gives you 4x squared? 2x. 2x times what gives you negative 6x? Negative 3. And 2x times what gives you negative 6x? Negative 3. So then your final answer is 2x minus 3 times 2x minus 3. Notice these are the exact same bubbles. So since something is being multiplied by itself, you can say it's that quantity squared. So 2x minus 3 squared. And yes, I would expect you to write it like this, okay? If you're multiplying something by itself, just write it as the thing being squared. So this is a binomial squared. So this is the reverse of that multiplication pattern, 7th and 8th period. Don't worry about that. But what you should notice is that in that list of the purple perfect squares that we just went over, what two numbers in our original trinomial are perfect squares? The 4 and the 9, because 2 squared is 4 and 3 squared is 9. Remember that. The next one, we are asked to factor 16y squared minus 225. We haven't really seen anything like this before because there are only two terms. Is there a common monomial? No, okay? So what we could say is that basically 16y squared, it's a trinomial, but that linear term is just 0y and then minus 225, okay? So kind of that's what it could look like. So if we were to factor that, your leading coefficient's not 1, so x in box, 16 times negative 225, negative 3,600. And then what number goes at the bottom? 0. So what times what gives you negative 3,600, but when you add them you get 0. You could list all of your factors of negative 3,600, or if you just think smaller terms, erase the zeros. What times what gives you negative 36, but when you add it you get 0. I don't know what just happened there. All right, so hopefully maybe it clicked. Since you're multiplying and getting a negative, but adding and getting 0, one number needs to be negative, but when you add two numbers together and get 0, wouldn't it make sense if they were the same number, but just opposite signs? So hopefully 60 and negative 60, or 6 and negative 6 came to mind. because 60 times negative 60 is negative 3,600, but when you add them, you get 0. All right, so now plug it into the box. And we've got our 16y squared, negative 225, 60y, and negative 60y. The greatest common factor of 16y squared and 60y, 4y. 4y times what gives you 16y squared? 4y. 4y times what gives you 60y? 15. 4y times what gives you negative 60y? Negative 15. So then your answer would be a 4y plus 15 bubble and a 4y minus 15 bubble. They are not the exact same bubbles. One is positive, one is negative. So you're done. That is our answer. So what do you notice about these two numbers? Okay, we started off with 16 and 225. Do they look familiar? They should. So 16 is a perfect square and 225 is a perfect square. So step number 2 of factoring. How to recognize if something is a special pattern, which means that you don't have to show work. If your first and your last terms are perfect squares, then it's most likely a pattern. This one is sometimes not always a pattern because that middle term is important. But for right now, I'm not going to trick you. If you ever see the first and last term as a perfect square, assume it's a pattern. But just know that that's not always the case, especially for the trinomials. All right, so we're going to name these patterns. The first one is called the difference of two perfect squares. I'm not going to say the. So it's the difference of two squares. The difference of two perfect squares. And what that pattern looks like is if you have some a squared minus b squared, okay? The first term is squared. The second term is squared. There's your two squares, your two perfect squares, but it's also the difference. So you have to be subtracting. Has to be subtraction, the difference of two perfect squares. That quickly factors into two bubbles. One is a positive, one is a negative bubble. And you take the square root of the first term, so a squared. If I were to take the square root of a squared, the square root and the square cancel each other out, and you're just left with a. So the first part of that bubble is an a. I need to shrink that down a little bit. Okay, so you get a, and that goes in the first spot of both of the bubbles, and then the square root of b squared. So you take the square root of the last term, and the square root of b squared would be b, and you're done. Okay. So let me give you an example. If I asked you to factor, I would say, give me a perfect square, but I really can't hear your feedback right now. So let's go with 36. So if I have 36x squared minus 25, okay, the difference of two perfect squares. Notice there's a variable in the first one, okay? So the difference of two perfect squares means you're going to have two bubbles. That factors to one bubble that has a plus sign, one bubble that has a minus sign. Difference of two perfect squares, two bubbles. The square root of the first term, the square root of 36x squared. You also have to take the square root of the variable. So the square root of 36 is Asking yourself what times itself gives you 36. Hopefully you said 6. And the square root of x squared. Is it x? So 6x is your first term in both of the bubbles. And then the square root of the last term, 25. What's the square root of 25? 5. That's the second term in both bubbles, and you're done. Again, if you needed to, you could refoil or rebox to make sure that you get what you started with, but you will. Okay, that's the difference of two perfect squares. That's like the second example that we just did here. So if we were to go back and look at that, the square root of 16y squared is 4y. 4y. The square root of 225, 15. The signs should take care of themselves. This is the difference of two perfect squares. And then in your bubbles, you'll always have one plus bubble, one minus bubble. Okay, the 1 plus and the 1 minus is what cancels out those two outer and the inner terms. Okay, one's positive, one's negative, so that middle term disappears, that 0y. So they have to be opposite signs. All right, the second pattern is called a perfect square trinomial. Perfect square trinomial. So the names tell you quite a bit. Trinomial meaning 3 terms. Perfect square. The first and the last will both be perfect squares. Okay, just like our first example here. 4x squared, 9. Perfect square trinomial. All right. Notice that when we got our answer, it was only one bubble that was squared. So if you have a perfect square trinomial, that means that your first term is going to be a squared. It's a perfect square. Plus 2ab, that's the middle term. Hang on to that thought. We'll get back there. Plus b squared. Okay, that will be the trinomial that you are given and asked to factor. Your first term is a perfect square. Your last term is a perfect square. That's what I want you to be looking for. The middle term here is a little more difficult, but second through fifth period, you should hopefully remember this from chapter 8 when we did those patterns of multiplying polynomials. So 2ab, 2 times the square root of the first term times the square root of the second term. That's how to know that it is for sure a perfect square trinomial, and we'll do one of those in the example. What that factors to is only one bubble that's squared. Okay, perfect square trinomial factors down to one bubble squared. The sign in the middle of the two terms is whatever the first sign of your trinomial is. So since it's a plus sign, this will be a plus sign. The first term in your bubble will be the square root of the first term. So the square root of a squared is a. And then the square root of b squared is b. Done. Let me give you an example. So if I have 100 x squared plus, let's say, if I got, let's just do, okay, 100x squared plus 180x plus 81. So 100 and 81 are both perfect squares. The middle term, 2ab, basically what you should notice there is that the square root of 100 is 10, the square root of 81 is 9, and that middle term is supposed to be 2 times a times b, so times 2. Well, 10 times 9 is 90, times 2 is 180. So there's where that middle term comes from. So this is a perfect square trinomial. That factors to one bubble that's squared. The sign is the first sign in the trinomial. The first term is the square root of the first term. The square root of 100x squared is 10x. Okay. Oh. The square root of 81, your last term, is 9. And you're done. Okay. So if you go back to our first example after this one, we'll be right back to that. The second part of your pattern in this pattern box is going to look very familiar. It's still a perfect square trinomial. If you have a squared minus 2ab plus b squared. So the only difference is that minus sign, okay? What that factors to is a minus b quantity squared. So the only reason I gave you another box here is because it's a slightly different pattern, but the only thing that's changed is the sign. So over here, let me give you another example. Let's say we've got 49x squared minus, let's do 28x plus 4. Okay, so we've got 49x squared minus 28x plus 4. So 49 is a perfect square, 4 is a perfect square. That middle term is 2 times a times b. A is the square root of the first term, which is 7, and b is the square root of the last term, which is 2. So 2 times 7 is 14. 14 times 2 is 28. That's where that 28 came from. But this is what you'll be given, and I'll say factor it. And you're like, oh, well, that's a perfect square trinomial. So it's just a binomial squared. Oh, it's the square root of the first term, which is 7x. The first sign is a negative, so it's a negative sign. And the last square root of the last term is 2. So my final answer is the quantity 7x minus 2 squared. Done. That's like what we had in the first example, okay? You had the difference sign there, okay? So perfect square trinomial, first and last. Notice 2x is the square root of 4x squared. 3 is the square root of 9, and it's a subtraction sign. Okay, so some examples. Example number 1, you should be able to identify what the pattern is, but also always look for that common monomial too. So 4x squared minus 25. Well, first of all, there are only 2 terms, and it's the difference of 2 perfect squares. So both of these terms are perfect squares. The difference of 2 perfect squares gives you 2 bubbles. 1 plus bubble, 1 minus bubble. The square root of the first term, so the square root of 4x squared is 2x. So that goes in the first spot of both bubbles. Let me make those bigger. There we go. And then the square root of the last term, just the number. You're not taking the square root of negative 25. Remember, that's imaginary. So the square root of 25 is 5. So that goes in the last spot of both of your bubbles, and you're done. The difference of 2 squares, 2 bubbles, 1 plus, 1 minus. Square root of the first term, square root of the last term. Square root of the first term, square root of the last term. Done. Example 4. Common monomial, 16x squared plus 8x plus 1. Nope. Is it a special pattern? I don't know. Let me check. Is the first term a perfect square? Is the last term a perfect square? Sure is. Excuse me. Since the middle term, you'll always want to check that middle term with the trinomial one to make sure that it does follow the pattern. So to check it, it's 2 times a times b. So a would be the square root of the first term, which is 4x. Times b, which would be the square root of the last term, which is 1. So 2 times 4x times 1 is 8x, which is right there. So yes, this is the perfect square trinomial, which factors to 1 bubble squared. The square root of the first term is 4x. The sign is a plus sign. The square root of the last term is 1, and you're done. Okay, so I want you to do number 5 by yourself. I want you to do number 7, number 8. I'm going to start number 6 with you, and then I'm going to have you finish it. Number 6, 98x squared minus 308x plus 242. 98, 308, 242. So what you should notice is that all of those numbers are even. So you can factor out a common monomial. So step 1, is there a common monomial? Yes. Divide them all by 2. So you get 2. 98 divided by 2 is 49. X squared minus 308 divided by 2. Just to double check myself here. 154 x, and then 242 divided by 2 is 121. Now what you're trying to factor is this trinomial, and what do you notice about the first and the last term? 49 and 121? Okay, so finish that one, and don't forget to reattach your common monomial at the end. All right, and those are our special patterns. Hopefully you enjoyed that, but again, if you forget the pattern, you can always do it the long way. So these are shortcuts, but if you forget the shortcut, you can take the long way around. If you didn't want to use the pattern, or if you forgot it, you could always just do the X in box for this. That would work. Your numbers are just going to be much larger, so it might take you longer, but you can most definitely do X in box method for this as well. If you wanted to do X method for this, since your leading coefficient's 1, you would just need to remember that you have a plus 0x term in the middle. So for your x, you would have to put a negative 16 and 0. Okay, but just remember that is still possible. If you forget the pattern, you can still do it the long way. All right, have fun and have a great day.